you are losing a lot of value if you can't make it. There's an enormous return on investment for any company that's paying a developer a reasonable developer wage and sends their developers here. I can't tell you how big of a mistake it is not to send someone to CppCon.
Good morning, friends of the community of C++ programmers. Thank you very much for having ruined your morning to come to this presentation. I hope that I'm going to make it work for all of you. The subject matter that I come to talk to you about is about data architectures for relocatability in your applications. And the purpose for that is to obtain performance. My name is Eduardo Madrid. And what we're going to end up doing is the opposite of pointer chasing. That'll be the alternate title for what we have to talk about. And let's start by enunciating what we're going to attempt to improve in our applications, okay? So, any non-trivial system will need to have objects that refer to each other using pointers in particular, and we need runtime polymorphism, like you have a base class and derived classes, and you want to substitute objects whose true type is of a derived class, while you are controlling them through pointers or references to a base class. Those things have nothing bad per se. This is the way that we normally do work in C++. The thing is that should we care about performance, if it would be truly important, like for example, in the case of video games that are pushing the boundaries of what the processors can do, the combination of these things will create a performance. We're going to revisit why those things create a performance. And we have the option to put a lot of effort into transforming our code so that we eliminate all of those performance leaks and do something much better. The option that I am going to be talking to you about is data orientation techniques in general, with extra attention to relocatability itself. We will define what is relocatability when it is a little more appropriate than at the very start of the presentation. But the general idea that we have here is, let's not confuse, if you came for something that was relocatability, has within the context of position-independent code, the relocation table for dynamically linked libraries, then this is unfortunately not the subject at all. I don't see anybody leaving, so I'm very relieved about that. And the application of data orientation techniques with an emphasis on being able to move the data to have freedoms and recover performance and benefit from that freedom. Why would we want to do that? Always to keep the data where it gives us the most performance. And let's begin to articulate those scenarios. I have a presentation at this conference from 3 years ago where I explained in a very C++-centric way, like the whole point of that presentation was to make it very relevant to C++ programmers to begin to use data orientation techniques, and the benefits to be obtained and how to apply them. I believe that presentation has aged very well. So that relieves me of having to explain everything today. If you are interested, because the amount of work to apply techniques of data orientation and relocatability is large, it doesn't make sense for you to just have the rough idea that I'm going to be introducing to you today. You should empower yourselves with more serious not serious, more comprehensive approaches to the subject, and I submit my presentation as one good resource. Especially because it is the only one that I have seen that is truly very C++ centric. The focus for today is empower us with freedoms to move things around for extra benefits than just plain data orientation. The meaning of data orientation is to give primacy to the data so that computations over the data have better performance than the normal way to design and architect systems. What is the normal way to design and architect systems? Well, we're going to be doing what we always do of organizing our data into classes and structures that have members of heterogeneous types. You can have a structure that has an integer, a Boolean, a floating point member. That's perfectly acceptable and the usual way in which we program. And if you want to refer to other objects, then you just put a member that is appointed to the objects that you want to refer to, or maybe even a reference. And if you use inheritance and virtual overrides, the limitations of that mechanism in the language will force you to transform what could be concrete members in your structures into pointers to base classes or references to base classes that refer to objects that have derived types. The problem with this, of course, is that this incurs the penalties of an extra indirection, lots of allocation. It introduces a heavy burden of a cognitive load of thinking about the lifetimes, the possibilities of sharing, because if it is truly expensive to do allocations for small objects, then you're going to have to minimize that. And to minimize that, then you're going to maximize the occasions in which you share state. And so those are the complications that emerge. I was saying in data orientation for the win 3 years ago that when you take it all into account, every time that you have a chain of an object in your design that internally refers to an object of a polymorphic type, and that polymorphic type in its own right refers to a member of a polymorphic type, then you have an exponential worsening of the performance with each level of using subtyping through the resource in the language of inheritance and virtual overrides. So it's in a way, from the perspective of performance, quite catastrophic. Now, if I was telling you about the normal way, then let's talk about the abnormal way. Subnormal, not just because nobody does it in that way, but because you have to put a lot of effort for non-apparent benefits, but the benefits are there. And one of the things that I did was to refer to all of the work that had been done on proving the benefits in terms of performance. Okay, so the way to give a primacy to the data can begin with transforming. So when you have an application that is not trivial, you will always have collections of objects of a particular data type, right? Those collections might be small, maybe large, that's not important, but most of the vast majority of the objects in an application will be in collections, okay? And if you have collections of objects of a particular data type, it doesn't matter whether they are a container that is a hash map or an array or some other data structure. Because the members of those collections, the members of the type of those collections are of heterogeneous data types. They have different data types. You will never be able to use, for example, the SIMD capabilities of the processors today of giving you easy to tap into parallelism, easy to tap into in other ways. If you had homogeneous data, you could tap into that. You have a problem of fragmentation, of enlargement of layouts, and many other problems, right? So this word salad is toward an alternative, and I believe that the alternative is described with an example that is very simple but representative, okay? Let's say that you are having a representation for the items that are sold or traded in a commerce site, okay? This is not realistic, but all I wanted to do is to just show you some example of a structure that has heterogeneous members. So you can have, for example, that the items have a field, a member, that is an ID. They have a price. I put it in double just because I want the thing to be very heterogeneous. It doesn't make sense in reality, but for the purposes of this presentation, I wanted something that has a very different type. You have a pointer to the specials of the trading on that particular item. And when you use a pointer as a member, there's always the question of whether the pointer can be null, that denotes some optionality to it, whether you are sharing, you are the unique owner of that pointer, and so on. So this is truly ambiguous from the perspective of the specification of the data layout, and has to be treated differently in what I am going to mention. Then there is a pointer to a category, and let's say that this is not a pointer that can be null. This is a pointer that will point to the category of the item, and there are only very few categories in the system. And this thing will share the category among many other things, but it will not concern itself with ownership of the category. So I hope that you are able to see that there are some arrows that indicate properties of interest. In this particular case, the ID and the price are contiguous in the data layout of the type, but they have dissimilar, very different heterogeneous data types. I was already commenting on the characteristic of this pointer, of whether it can be null or not. I told you that category is a pointer to a valid object, that these data types do not participate in ownership, and a Boolean. What is the problem with Booleans in normal structures? That even though they may be necessary, they are performance hostile.
Sorry, could you enlarge the PowerPoint?
Yes.
Go back to
Yes, I am. Now that I can modify it, thank you for the feedback. I am modifying it to make it larger, and the presentation mode is going to be more helpful, right? Are you able to read at this point? Excellent. Okay, so I was saying that the Booleans may be necessary, but they create a memory layout inefficiency that can be quite large in relative terms to the rest of the application. Okay. Now, other people and myself have explained how to evolve from the normal representation of the state of our objects in a system toward something that is very friendly to the execution resources. So the very first thing that we have to bear in mind is to attempt to evolve from heterogeneous collections of data towards homogeneous collections of data. And this is commonly called evolving from the normal representation into a structure of arrays of homogeneous data. So we have here the structure that internally contains arrays. So because every object of the class item has the fields of ID and price, it makes sense that the structure of arrays that you're going to use to represent those fields are simple arrays of the necessary data type, in this particular case, integer and double. I want you to observe that the pointer specials had some special semantics to it, and much better than representing it as an array of something, we can have an efficient map. And why an efficient map? What do I mean by this map? That perhaps very few of the items have specials associated to them. So instead of having an array that is going to be densely populated and wasting a lot of memory for items that do not have specials, then you just make a map here for the few who do have specials to keep track of that part of their semantics and their state of execution needs. And when I was saying that I refer to a category, then I have switched a pointer to, I have a slide where this, of course, ought to be an array there. When I had a moment ago pointed to a category, now I have an array. And the Booleans, it might be a sensible choice to represent Booleans as a set as opposed to an array of Booleans. And of course, the binding between the objects that originally were of this data type of item to the individual members that they have, is the index, okay? So the index is what represents is what allows the binding between the item and the individual data members that they require to function. I call this the column-wise representation because it has the word wise in it, and especially because the database people have been doing analysis of when it is a good idea to represent tables as collections of rows in which each row, of course, have data elements of different types, versus representing rows as collections of columns in which each column will have homogeneous data types. Yes, Peter?
Is your homemade missing the bool, an efficient set of just size t?
Thank you. It is that.
How would you map it back to which array it was in?
Okay, Peter, thank you for your question. The question, I think, is how do you know which part of the set belongs to a particular item, right? We are not seeing it here, but efficient set is a template that takes a template argument just because of the implementation would give the programmer a choice of how to internally group things. So that was an artifact, but let's call it just a set. So a set in this particular example can be, if I introduce this again, the sets either contain or not contain members of the domain, right? If the domains are the integers, if the domain are the indices, then the relation, again, between an scattered or column-wise representation of items to the item, the thing that binds them together is the index, okay? So all of the things that have the same index in the structure of arrays refer to the same item in this particular example. Does that clarify, or should I try again?
Not really, because I see we're using the index, but how do you tell what is true or false?
Okay.
If an index is in the set, then it's homemade.
Okay, all right, got it.
Yes. I'm happy that the audience was understanding it, so it's good. Huh?
You've got your audience with you.
Yes, but you are also part of the audience, so don't abandon me just yet, okay? Give me more opportunities. All right, a column-wise representation. So we have homogeneous data types, or we have transported the original semantics into things that gives us performance benefits. So what I have been doing is described very well into the general concept of entity component systems. I choose this morning to not tell you too much about entity component systems because I am not really an expert on them. By the way, I have never programmed games, not professionally. And feedback that I got from before is that I should have made it real clear that once you do the operation of scattering, of transforming from the row-based or the normal architecture and design to the structure of arrays, or what I call column-wise representation, that we don't have objects anymore, not in the conventional sense. So we had to refer to the things in a different way. So let's use the word of entities. And what used to be members of the objects are now components of an entity. That's a very easy to understand language, and I don't need to stress too much on the fact that I am a newcomer to entity component systems. And there is a third thing, which is the system, which is what binds the entities to their components. And I have just introduced for you that the primary way in which an entity is bound to their components is because the entity has an index, and the index is what binds the entity to the individual data members that you want them to have. And the abstraction that we need, that I smuggle it into this slide because I am having an array of category handles, is what I explained 3 years ago of a generic programming concept of a handle. And what is a handle? Underneath are just an integer, which is the index to the components. And the transformation that we do for the purposes of using our entities is whenever we used to use structs or classes directly, we're going to be using handles. So this would be the handle for the type of item that we were working with before. And you just convert what used to be data members into accessors. And at this point in time, you decide whether they are modifiable or not. And when you are doing the programming, you're just going to be substituting the use of a member by the use of the accessor. So it is non-intrusive for the, well, conceptually, cognitively, not intrusive for the user. Although the user, of course, needs to do the substitution, because now they will be using handle instead of the original object types. Yes.
On the previous page, since you're storing the specials in a map, isn't that going to create an entry in the map? Don't you have to check if it exists in the map?
Yes. Thank you for the question. The question is whether because the implementation of the accessor of specials just uses the bracket operator on an index. If the specials, if that item doesn't have specials, whether this invocation to this bracket operator is going to create a new object, as in the case of a normal standard map. Okay, thank you for your question. You are very attentive, but this is not a standard map. This is an efficient map. And the efficient map doesn't have that behavior. It probably, you can make it so that it throws an array, it throws an exception, for example, or do something else. Because maybe the handle, and again, thank you for your question. What is your name, sir? Greg, thank you. There should be probably in the handle another accessor which tells you whether it has an specials in the first place. Mm-hmm. A question about the implementation of efficient map, yes?
Yeah. So basically, usually, you want, when you're using data-oriented programming, you want to be cache-friendly.
Yes, the question goes that when you do data-oriented, you want to be cache-friendly?
Yeah. And usually maps and sets are not cache-friendly because they're scattered around the memory. So is efficient map localized?
Yes. So the objection to the use of a map is that they scramble things around. They have bad memory fragmentation properties. They have an indirection in there and so on, right? And all of those things are true. But I am introducing the prefix of efficient for a reason. So you make it be the semantics that best suits your particular needs, okay? You have choices and you just do what works best. And I call it efficient map precisely for the kind of questions that Greg asked, that this is not the typical on-order map. We don't want that semantics. That semantics is inadequate. So thank you very much, guys, for complementing the slides with your questions. That's the whole point of being live in an audience.
So I want to go forward with this. Can we change efficient map and set to flat map and set?
Yeah, that's a good question.
Sorry, we have a difference of opinion, and I don't believe that it needs to be part of the recording on of the application, okay? But I truly thank you for the comment, because even if we have a difference of opinion, we are very much in sync about what is the objective, and we are thinking very decidedly about the paths towards that objective. Okay, why are we going to do this work? Because computing with homogeneous data can extract full performance from the execution resources. The execution resources can be CUDA cores, they can be SIMD, they can be weird assembler instructions in the processor that you're using, and others. So we have substituted tragically inefficient, from the perspective of performance mechanism of allocations, to having to deal with indices, meaning slots, whether a slot is available or not, and supporting change in some way. Very purposely, I have not told you this morning anything about how to change things, what happens when the objects get created or deleted, and the representation of the entities in the entity component system model of it. There are other things that are less obvious, but very important themselves. There are disincentives to communicate via state changes when you evolve from the normal architecture into the columnar-wise representation, the scattered representation, or the structure of arrays. And why are we doing to do this work in general? Because we can put data where it will be used for the best performance. So that will end the recapitulation of what I introduced for data orientation, but I really invite you to revisit that presentation, because I see the interest on diving into the details, but this is not about just data orientation. We had to focus on relocatability. One thing more that I didn't mention before. because of pointers, if you want to persist the state of execution of your application, you cannot just do something simple as a few memory dumps to file. It won't work. No, number one, because the allocators give you the objects or the locations for the objects spread all over the memory. That's unpredictable, and you will have gigantic holes, so you're not going to persist 4 gigabytes for, let's say, 100 megabytes of actual data in your application. That wouldn't make sense. Because, again, this is the places where allocators are going to put things for you. Well, the places that allocators are going to give you so that you can put things on them will change randomly, basically, without any control, between invocations of the same application. So if you start the same application a second time, the positions are going to be entirely different, and it won't just work. But if you remove that hard dependency between the location of things, the location of your objects, I want you to observe that in the case of the representation column-wise has a structure of arrays. Well, you can have the structures of arrays in different places, but you can preserve the semantics of the relationships between your objects has entities whose components have different indices. Sorry, have the indices, the components have the same indices. So relative to each other, as long as you move everything together, you're going to be able to just take a memory dump of the original structures. And by the way, that's another difference of an efficient map over a map in which the thing is ready to be persisted as just a dump of its binary contents. I was saying, to the next invocation, you have the power to make it so that the relationships between the entities will continue to have the very same indices. And that would allow you to just move the arrays, preserving the semantics of your whole application. By the way, I'm glad that you guys picked up that I love to be asked questions during the presentations. So, but now will be the time. Do you guys have any question at this point? All right. Yes, your name?
When you're going over the pros and cons of...
Please use the microphone.
Hi, when you're going over the pros and cons of the data-oriented approach, so one thing you were saying is in the old approach, or the regular approach, you have all these pointers.
Yes.
So now when you create an item handle that points to the global collection of data, now you have an extra pointer to worry about, right? So like, I'm wondering who generally owns the item handle, and isn't that an issue too, that you have to keep track of the lifetime of that item handle?
Yes, thank you for your question. It's an appropriate question. You want to know more detail about, in particular, the system part of the entity component system, all right? Just to be clear, the handles, they don't know anything about where the structure of arrays is. That's given to them by the system.
Okay.
So
the global...
In particular, the simplest of all systems, as in the meaning of system for entity component system, is to just have one global structure of arrays. And at that particular case, the handles don't have to have a reference to it. It is the linker of the application itself, the one who is going to introduce on each of the individual accessors the address of the global structure of arrays. And the performance of that is negligibly worse than pointers.
I guess like it's just more, this is more abstract, but if an item is deleted from the global struct of arrays, and then if the item handle still persists, then we have to worry
hold on
about
a moment. You won't remove an item from the global structure of arrays, you would remove an index, right?
Right, right.
Okay.
But then if the item handle still persists with that index, like we have to worry about.
Well, so you will be deleted. So you will be the equivalent of deleting a pointer that continues to have live references to it.
Yeah.
Okay, so that will be a conceptual error that it has nothing to do. It has nothing, no special attribute to that error for being in an entity component system.
Right.
We agree on that, right?
Yeah. I'm
Excellent.
just saying, like, there's still some bookkeeping and like, thinking.
Yeah, I mean,
cognitive load. Like,
the system is something that needs to take care of those things. Yes. I have an example of a simple system later on. All right. This is going great. The audience continues to be in sync because they just want more detail, and that's wonderful. Thank you for your engagement. So there's another problem, which is allocators in general don't care about you. And much worse than that, they care absolutely nothing about the efficient locations for your data. So you have to assume a lot of work yourself to be able to put data where it is efficient to use. This is inherently unavoidable. And a lot of the reason for why data orientation requires some work. But the conclusion of this is that you absolutely must be free to move your data. And then we're introducing the actual concept of relocation. So I just got a question that implied state changes. So as the application continues to run, lots of objects are created and destroyed, obviously. And then the maintenance of the slots in the arenas, in these spaces that have structures of arrays, will begin to have holes in them, will have experienced the problems of fragmentation, and the whole thing will resemble allocation of the allocation. But of course, a much easier problem because managing slots is just to determine whether an index is available or not. In the case of allocation, you have the really nasty problem of different sizes of allocation, okay? So this is an homogeneous size, so it's a much easier problem to tackle. And if we want to support change, okay, as usual in computer programming, we might avail ourselves of the conceptual resource of introducing another level of indirection. So you can have stable indices, meaning that during the lifetime of your entities, they will never change the index that they refer to, but they don't need to be on a particular array at a particular location because you can have that indirection that tells you what is the real index in the storage for the components of that entity. So you keep the original index stable so that you preserve the semantics of all the relations, but you are able to move underneath within the storages the objects that you started with. And this is, if you think about it, the only reasonable way to support change. I am very lucky because I was going to explain that in sufficient level of detail to get people to understand the work to do when the benefits in performance of relocatability, but right before right after we got the announcement of the acceptance of this presentation, it turns out that Björn Fahle at C++C dedicated an entire presentation to the subject matter. He did a wonderful job. I do agree with his conclusions. I think that his conclusions are representative for real-world scenarios. He did not present a realistic use case fully fleshed out, but the individual proof of concepts are, in my opinion, representative of what would be real world. But of course, this is a speculation on my part because I have never done this in production myself. So And this is the presentation. It's called Cache-Friendly Data and Functional Ranges. So I need to recap his presentation on C++ on C 2024. He calls stable indices stable IDs. And the technique is to use an extra indirection that pays for itself in terms of performance. A forward map that says, from this stable index, the data is going to be located on the structure of arrays using this other index. That will be the forward map. Furthermore, you might require, for application needs, to also maintain a backward map in which the storages have the indices of the entities that refer to them. And the combination of the two seems to be an expensive thing of an extra indirection, which, yes, it does have a performance implication, negative, but also the problem of the lessening of cache locality and so on. Well, he does a very good job, has in the title of the presentation that all of this is actually cache friendly because it increases the time and space locality of the accesses to the data. I can try to replicate his presentation this morning, but again, if you're interested in this topic, it doesn't make sense to just have a bad or too short presentation on that topic if the resource that explains it real well already exists. All the role that I want to fulfill today is to make you aware of the performance implications, the conditions, to have a feel for it all, and to motivate you to study further if you begin to think that this is something that might be suitable, amenable for your needs. What are the advantages of relocatability on top of, relocatability? To achieve relocatability, you need to first achieve data orientation. So it is, again, to reiterate the predictability and control of where the data will reside. And of course, that it will reside where you think is best, where you think is going to give you more performance. Another thing is that saving the state externally is just a memory dump or a collection of memory dumps, which is so much easier, so much more performing than the process of creating a serialization infrastructure that will traverse relationships between objects and serialize them. And the opposite of deserialization would also create a flood of small allocations, and it's going to be a host of problems. I hope that you see without me having to dive too much into how many of them. And this can be maintained even as a memory mapping at the operating system level, like a memory map file, for example. 3 years ago, they were telling me, hey, could you not have the state of your application for a multi-threaded application be maintained as memory mapped so that different threads, when they modify memory, then the operating system takes care of making a copy on write, and then that relieves people from problems of synchronization and so on. And so, wow, that's a really good thing to have mentioned back in the day. It's true. Now, there's another more subtle thing, which is when the application is running, you might see that your components and entities are what I'm going to call intuitively shaken, not a technical term, and then they become not efficient anymore. And the benefits of relocatability is that it would allow you then to put them back to the places where they are going to be efficient again. I'm just going to give you some examples of what I mean here. So when entities get removed, they are going to be leaving holes in the structures of arrays, right? Slots that are not used anymore. So if you have, for example, something that will traverse the entire collection of homogeneous data elements, now you have to make the proviso that some of those indices will not have a valid data member in them. So a valid value in some holes. And you can do that, or perhaps you can keep your structure of arrays by applying a mechanism of the fragmentation every time that it is necessary. Another thing is that, let's say, for example, that you remove an entity from the beginning of the structure of arrays, and then you add a new entity, so you require a new index, and you may reuse the old index, but then it breaks the familiarity, the space locality between the new item that presumably can have locality with footed new items or the latest items that were added. And now they are in a position where they don't have the same locality with the members that they have the access pattern. Or this process can introduce the problem of false sharing, okay? So do you know, show of hands please, false sharing, do you understand what false sharing is? Oh, all right, I don't see many hands up. The memory architectures, when you write to, let's say, an integer, what you are asking the actual processor to do is to bring in the cache line where the modification is happening, change only four, let's say an integer would be 4 bytes. You're gonna change 4 bytes of the entirety of the cache line, which is 64 bytes, and write back the entirety of the cache line to memory, which is 64 bytes. So you made a change of 4 bytes, but you ended up using resources, computational resources, memory bandwidth for 16 times that. So that's inefficient, right? But if you have together two data objects that are written frequently, then you can make it so that all of the people that contains the value of one of the members need to update by fetching the cache line every time that the other thing gets modified. So this worsens the performance of the entirety of the application infrastructure. The problem is called false sharing. And it is a severe performance pitfall when it occurs. And it's hard to predict when it will happen and so on. So this is one of the reasons why it is important to be able to have control and predictability with regards to where things are going to be located. That's the way to prevent the performance pitfall. Okay, so what's essential for better memory performance? Obviously, improving time and space locality. That's the whole point of it all. So if your design has a priori knowledge of how to increase time or space locality, relocatability in general is going to be the set of techniques that is going to allow you to accomplish benefits from that. A simple example, you are in a video game that has a very large map with millions, tens of millions, hundreds of millions of objects, and the player is moving in that map. So very intuitively, you can see that the objects that are close to the player are far more likely to be interacting, to be hot, to be used frequently. And then you can do something like, for example, moving those things to a part of the memory where they are all together so that they have much better time and space locality. It is relocatability, the thing that's going to allow you to capitalize on that a priori knowledge. That is hopefully an example that clarifies things. Okay, we are getting very close to the end of the presentation. And let's comment on what other things could help, okay? By the way, this is the most valuable part of the presentation, but it's the hardest to get, so let's see how we do. When you are in production, we are past proof of concept, small things. In my attempts to productize the work that I have been doing, I have stumbled upon something that is truly important, and that I believe is a discovery of the people at Bloomberg that Nina Rance in particular made me aware of it, and which is this. And look that data orientation has a lot to do with a standard optional, and I'm going to show you that link right away. You can have vocabulary types, like one random example of a vocabulary type that exhibits this problem is a standard optional. And a standard optional of a type itself, the standard optional doesn't need any allocator. It is not concerned with allocation because it doesn't do allocation. It can configure itself a compilation time to be of the internal buffer size and alignment suitable to hold whatever it is going to be holding optionally. But there's a problem. Imagine that the scenario that it is an optional that contains or holds potentially a standard vector. The standard vector does require to do allocations, and it has a template argument for the custom allocator itself. So currently, when you have something like an optional that internally has a value of a different type, there is absolutely no way to access the internal concerns, the internal template arguments of the thing that are going to be inside from the outside. There is a hard block that prevents this in the middle. And I stumbled upon this concept when I was working on my type erasure framework, that in the case of type erasure, there are very plentiful concerns that need to be respected from the outside to the inside of the values that are going to be managed. And type erasure itself has its own value management concerns. One of them is, for example, whether the thing that is going to be managing your values in type erasure are going to be locally managed, whether you want to disallow them to not use what in the very poor standard function implementation is called the local buffer optimization. I think that this is a concern of value management that is quite important, and it has two concerns of its own, which is the buffer size and the alignment. If it is not going to be local, you're going to allocate something on the heap, then what are the choices, strategies for the allocation that you want to have? How are you going to hide the indirection? So what I'm going to is that all of these things don't have any lever, any interface for the programmer to inform internally or the objects that are going to be handled, how they need to be handled. And this is really, really important for the purposes of the transformation of the normal to the column-wise representation, because in any realistic scenario, you're going to be interfacing back and forth between the normal representation and the column-wise representation, and that creates a universe of challenges that need to be addressed. So this adds understanding to the problem of the lack of a value management concept in the standard library. And I believe that the only choice to articulate the concept of value manager is to use Andrei Alexandrescu's policy design pattern. And thank you very much for your attention. We're just going to talk about the conclusion, which is the language needs to improve some capabilities, in particular reflection, and in particular the sub-aspect of reflection of introspection, because otherwise this amount of work of the transformation from the normal to the column-wise is quite fraught with effort and peril. Libraries need to improve support for scattering and handles. we programmers need to avail ourselves of data orientation and relocability techniques more often, because we are letting go of ever-increasing performance because, the SIMD architectures are getting larger and larger, so there is larger and larger performance that we leave untapped. The value management concerns emerge also within relocatability and data orientation. All right, thank you very much. I'm ready for a couple of extra questions in 22 seconds, and I really thank you for your presence today. All right, it seems that the memory, the mind sync between the audience and the subject matter was so good that at the end nobody wanted to ask questions. Thank you very much, Matt.